Hello everyone, here is the first video of Review 1 for Quiz 2. This is it, just 3 types of problems. I have 2 parts for each one. So feel free to copy all these down, give them a try, look back in your notes, and then proceed watching the rest of the video to check your answers and see how these are worked out. Alright, so if you're ready to check or you just want to follow along the first time, let's go ahead and get started. So I will point out on the quiz, it'll look very similar to this, like the first 2 problems, or I might just give you 1 problem on the quiz, but I will mention to use integration by parts. Let's take a look at 1a. We want to evaluate the integral of x times e to the x dx. So notice this is a product. So even if I didn't mention integration by parts, the fact that this is a product tells us to use this. So we're going to try, let's let u just equal the x. We always want that to be the simpler. When we go to take the derivative of this, we want it to become very simple to work with. So u is going to equal x, then we'll let dv equal e to the x dx. Therefore, du is just going to equal dx, and v, the antiderivative of e to the x, is just e to the x. So this integral now becomes, remember, it's u times v, so x times e to the x minus the integral of v du, so e to the x dx. And that's a pretty basic one, so this problem is probably as simple as they get for integration by parts. So we still have this first part here, and then we'll take the antiderivative, which is just so minus e to the x, and then a plus c. All right, question B, we have the integral of 8x times cosine of 4x dx. All right, so for this case, let's let u again equal the simpler of the 2 factors, 8x, and then dv is going to equal cosine of 4x dx. So then du is going to equal 8 dx. V is going to equal, now this is the easiest way I would try to advise you on taking the antiderivative. So it's going to be a positive sine of 4x. So when you get to this part, if you ever question yourself, should it be negative, should it be positive? At this point, take the derivative. The derivative of sine of 4x is going to be a positive cosine, so I want this to be positive, of 4x. But then I would need to multiply it by 4, so to get rid of that 4, I need a fraction of 1/4 out in front. So now this will become u times v, so that's 8x times 1/4 sine of 4x minus the integral of v du, so that's going to be 1/4 sine of 4x times 8 dx. So I'm going to simplify this first part, so we're going to get a 2x sine of 4x. Now if you left it this way, that would still be okay. Now over here, I'm going to take the 1/4 of 8 and I'll put that out in front, so minus 2 times the integral of sine of 4x dx. Good news is we're not going to need to use integration by parts again. We just simply take the antiderivative here. So we have 2x times sine of 4x, and then minus 2. Now the antiderivative of sine is going to be a negative cosine of 4x, and then I would still need, just like over here, I would need a 1/4 out in front, and then a plus c. So again, if we took cosine of 4x, we would get a negative sign, so that's why I have the negative here in the 1/4, because then we would also need it times 4. So again, I'm fine if you want to leave it like this, but completely simplifying this, this will become a plus a 1/2 times cosine of 4x plus c. Now remember, you can always take the derivative of this, and then you should get the original expression that we're taking the integral of. All right, let's take a look at number 2. Okay, so 2a, this goes to section 7.2. So this is, we're going to evaluate the integral of sine theta cubed times cosine theta to the 4th d theta. So this is where you really want to go back to the notes from section 7.2. So here we're looking at the strategies for the integral of sine x to the m times cosine x to the n dx. So part A says if n is odd, but n is the second exponent, that's definitely even. So then part B says if m is odd, and that's the 3 here, save one sign and use substitution of sine square x is equal to 1 minus cosine square x. So you definitely need to go back and take a look at the strategies for the sine and cosine, and then tangent and secant. All right, so again, this says save one sign. So that means we're going to factor out a sign here. So now we'll have sine theta squared times cosine theta to the 4th d theta. Then this is times sine theta. Actually, I'll put the d theta after that. All right, so now I want to, again, the substitution is to replace the sine theta squared with 1 minus cosine theta squared. So now this is the integral of 1 minus, I'm just going to write it this way, it's just easier, less parentheses now. So 1 minus cosine squared theta times cosine theta to the 4th times sine theta d theta. Now, if you ever forget the u substitution here, we want du to equal sine theta d theta. So we're going to let u equal cosine theta. Again, that's what the strategy said. That way du is going to equal, well, in this case, a negative sine theta d theta. So now this becomes, I'm just going to put that negative out in front. So we have the opposite of the integral of 1 minus u squared times u to the 4th, and then we have du. So now I'll just distribute u to the 4th, so we'll get the integral, the opposite of the integral of u to the 4th minus u to the 6th du. And now we could take the antiderivative. So we're going to get the opposite of, we'll have u to the 5th over 5 minus u to the 7th over 7 plus c. And now we just want to bring back that u is equal to cosine theta. So we will have the opposite of, we'll have cosine theta to the 5th over 5 minus cosine theta to the 7th over 7, and then plus c. All right, let's try 2b. We want to evaluate the integral of tangent x cubed times secant x to the 5th dx. All right, so from our notes, the strategy here, the first part says if a power of secant is even. We don't have that case. B says if the power of tangent is odd. We do have this case. So we want to save a secant x tangent x factor. So let's go ahead and do that first. So this will become, we want to factor out a tangent x. I'll take that down to square, and then secant x to the 4th. And then we have a secant x tangent x dx. And then we want to use the substitution that tangent square x is equal to secant square x minus 1. So that's this first part right here. I want to rewrite this as secant square x minus 1 times secant x to the 4th. And then we have secant x tangent x dx. So now, what's going to give us this as a derivative? If u is equal to secant x, because notice everything else is in terms of secant x. So then du is going to equal secant x tangent x dx. So now this becomes the integral of u squared minus 1 times u to the 4th times du. Like the last problem, we'll distribute. We'll get u to the 6th minus u to the 4th du. Take the antiderivatives here, so we get u to the 7th over 7 minus u to the 5th over 5 plus c. And we bring back that u is equal to secant x, so we get secant x to the 7th over 7 minus secant x to the 5th over 5 plus c. All right, for 3a, we want to evaluate the integral of x squared over the square root of 25 minus x squared dx. So the problems, both parts for number 3 are from section 7.3. So this is where we want to use some trig substitution. All right, so if you notice what's underneath the square root, this is like we have the a squared minus x squared. So in this case, you want to identify those or remember those trig the table of trig substitution. So in this case, we want to let x equal a times sine theta. So a is the square root of 25. So we get 5 times sine theta. And then dx is going to equal 5 cosine theta d theta. And then we'll go ahead and replace all of our x's with 5 sine theta. So up top, we're going to get 25 times sine square theta. As I square 5 sine theta squared will give me 25 sine square theta. And then we have 25 minus, and again, if I square x, I get 25 times sine square theta. And then dx is equal to 5 cosine theta d theta. So I'll still leave my numerator the same for right now, but it's underneath this radical here in the denominator. I want to factor out a 25. This will leave me with 1 minus sine square theta. And then I use a Pythagorean identity here, that this will still give me 25 sine square theta up top over the square root of 25, and then 1 minus sine square theta is cosine square theta. So now this denominator is going to simplify to 5 cosine theta. And hopefully you notice, if we were to multiply by that, that's going to divide out. So these two divide out. Put the 25 on the outside times the integral of sine square theta d theta. So now, I did an example like this in class with cosine square theta. The Pythagorean identity is not going to help us here. The half angle identity is. So I want to rewrite this. This becomes 1/2 times the quantity of 1 minus cosine 2 theta. And I could pull that 1/2 out, so we'll have 25 halves times the integral of 1 minus cosine 2 theta. So now I can take the antiderivative of this. So this will just give me theta minus, and again, I'll have sine of 2 theta, because remember that little trick I just showed you in the other problem, how we can think of this. The derivative of sine of 2 theta will give me cosine of 2 theta, but then times 2, and this 1/2 is just there, so I'm going to have to put, or the minus sign is just there, so then I'm going to have to put the 1/2. So the derivative of a negative 1/2 sine of 2 theta is going to give us a negative cosine 2 theta times 2, but then times this 1/2. So we'll get this up here, and then plus c. So now we reach the point where we can't do anything else, but we want to take that theta and put it back in terms of x. So this is where I draw the right triangle off to the side. So I go all the way back up to the top here. X is equal to 5 times sine theta, which means sine theta is equal to x over 5. And I draw the right triangle. So that's opposite over hypotenuse, which means the adjacent side here is going to be the 5 squared, the square root of 5 squared minus x squared, so 25 minus x squared. Now remember, you know you're doing that right because that should match what's under the radical at the very beginning. All right, so I actually have to do a little bit more with this. I'm going to rewrite, if you recall, I also mentioned this, sine of 2 theta, there's an identity for this that's equal to 2 sine theta cosine theta. And that's what's going to help. So I'm going to have 25 halves, and we'll have times theta minus 1/2 times 2 sine theta cosine theta. So that means now I need to represent cosine theta off to the side. So cosine is adjacent over hypotenuse, so that's the square root of 25 minus x squared all over 5. I also need to represent theta, so if sine theta is equal to x over 5, then theta is equal to the inverse sine of x over 5, or arc sine of x over 5. So now, my final answer, leave the 25 halves out here, we're going to write inverse sine of x over 5 minus the 1/2 times 2 just turn into a 1, and then we have sine theta, which is x over 5, times cosine theta, which is the square root of 25 minus x squared all over 5 plus c. Now you could leave it like this, or you could take one step further and just say x over 25 times this, but this is perfectly fine. All right, and then our last example. We want to evaluate the integral of 1 over the square root of x squared plus 4 dx. Right, so this is a case where we have x squared plus a squared. So when that happens, we want to let x equal a times tangent theta. So a is going to be 2, the square root of 4, times tangent theta. And then dx is going to equal 2 times secant square theta d theta. So now I'm going to go ahead and rewrite this as 1 over, if I square 2 tangent theta, I'm going to get the square root of 4 tangent square theta plus 4 times 2 secant square theta d theta. So I'm going to factor out a 4. So then we have 4 times tangent square theta plus 1 times 2 secant square theta d theta. Then I'm going to use the Pythagorean identity. Tangent square theta plus 1 is equal to secant square theta. Take the square root of this denominator, and we get 1 over 2 secant theta. And we notice we can simplify some things next. So the 2's are going to divide out, and I'm left with the integral. I have 2 factors of secant up here, 1 down here, so we're going to end up with secant theta d theta. Now we took the antiderivative of this, if you recall, it's the natural log of the absolute value of secant theta plus tangent theta plus c. So at this point, this is where, again, x is equal to 2 tangent theta. We want to make our right triangle. So this means that tangent theta is equal to x over 2. So that is adjacent over, opposite over adjacent. So that means we have the square root of x squared plus 2 squared for the hypotenuse, which is that x squared plus 4, which again was part of our original problem. So to represent secant is the reciprocal of cosine. So cosine would be adjacent over hypotenuse. Here we would have hypotenuse over adjacent. So now this is equal to the natural log of the absolute value of the square root of x squared plus 4 over 2. And again, tangent theta is x over 2 plus c. All right, so we'll do similar problems in review 2.